Imagine standing on the shores of the Akashi Strait in Japan, staring out at one of the most violent, treacherous, and deadly bodies of water on the entire planet. This narrow oceanic bottleneck is a brutal, chaotic war zone of nature, where the Seto Inland Sea violently collides with the open Pacific Ocean, creating aggressive, swirling whirlpools and terrifying tidal currents that can easily tear a massive ship completely off its course. For centuries, this strait was a graveyard for sailors, but in 1955, the absolute brutality of this water reached a catastrophic breaking point when two passenger ferries violently collided and sank in a severe storm, claiming the lives of 168 children. In the wake of this horrifying tragedy, the Japanese government made a highly ambitious, deeply arrogant, and seemingly impossible declaration. They decided they were going to permanently conquer the Akashi Strait. They were going to build a bridge straight across the violent ocean, completely eliminating the need for dangerous ferry crossings forever. But civil engineers immediately realized that building a bridge here was an absolute mathematical and physical nightmare. The water in the strait plunges to a terrifying depth of 110 meters, the oceanic currents scream past at a violent 4.5 meters per second, and the entire region is frequently battered by apocalyptic, high-speed typhoons. Even worse, the strait sits directly on top of the Pacific Ring of Fire, a highly active geological war zone infamous for producing catastrophic, city-leveling earthquakes. To build a bridge here meant intentionally designing a colossal megastructure that could simultaneously survive being battered by deep-sea currents, blasted by Category 5 hurricane winds, and violently shaken by the most powerful tectonic forces on the planet. Japan was not just planning to build a suspension bridge. They were preparing to construct a multi-billion-dollar brutalist fortress of high-tensile steel and ultra-dense concrete that would completely rewrite the known limits of human engineering and hold the title of the longest suspension bridge in the world. The terrifying war to conquer the Akashi Strait had to begin in the absolute worst place imaginable, deep underwater, at the bottom of the violently churning ocean. You cannot suspend a multi-million-ton steel highway over nearly 4 kilometers of open water without an unyielding, practically indestructible foundation locked permanently into the bedrock. Because the water was far too deep and the currents were far too violent to build standard cofferdams, engineers had to invent an entirely new, deeply radical method of deep-sea construction. On the dry land, they manufactured 2 colossal, heavy-duty steel cylinders known as caissons. The sheer, brutal scale of these steel rings is mathematically incomprehensible. Each caisson was 80 meters wide, 70 meters tall, and weighed an astonishing 15,000 metric tons before it even touched a single drop of concrete. They were essentially hollow steel skyscrapers built on land, designed to be violently sunk into the ocean. In a terrifying, highly calculated ballet of heavy marine engineering, massive fleets of high-powered industrial tugboats hooked heavy steel tow lines to these colossal cylinders and dragged them out into the violent cross-currents of the Akashi Strait. Utilizing advanced military-grade GPS and acoustic positioning transponders, the engineers had to navigate these massive steel leviathans into the exact mathematical center of the roaring ocean with a zero-tolerance margin of error. Once they were perfectly aligned over the pre-dredged submarine foundation beds, massive industrial valves were violently thrown open. Millions of gallons of aggressive, rushing seawater violently flooded the hollow steel chambers, intentionally destroying the caisson's buoyancy. Slowly, brutally, the massive steel cylinders descended through the dark, murky blue depths, crashing into the ocean floor with an immense, ground-shaking kinetic impact that permanently embedded them into the deep tectonic crust. But a hollow steel ring is not a foundation, it is just a mold. To give these deep-sea fortresses their absolute, uncompromising strength, engineers had to completely fill them with concrete. However, pouring standard liquid concrete through 100 meters of fast-moving, violent ocean current is an absolute impossibility. The aggressive salt water would instantly dilute the mixture, washing away the binding agents and leaving behind a useless, crumbling pile of wet sand. To solve this fatal materials crisis, Japanese scientists completely reinvented the chemical composition of industrial concrete. They developed a highly advanced, ultra-dense, self-compacting underwater concrete that was specifically engineered to aggressively resist water dilution and cure into a rock-solid, impenetrable mass, even when fully submerged in a violent oceanic abyss. For 3 continuous, agonizing days and nights, massive fleets of heavy marine concrete mixing ships surrounded the sunken caissons. They deployed colossal, heavy-duty pumping hoses deep into the ocean, aggressively injecting 265,000 cubic meters of this newly invented, highly volatile concrete directly into the steel cylinders. As the concrete aggressively cured underwater, it generated an immense, terrifying amount of thermodynamic heat. If this massive thermal energy was not strictly controlled, the concrete would violently cook itself from the inside out, causing massive structural stress fractures that would guarantee the eventual collapse of the bridge. To neutralize this microscopic thermal threat, engineers had embedded an intricate, highly complex vascular network of cooling pipes inside the caissons, constantly pumping chilled water through the curing concrete to artificially freeze the thermal reaction. The result was two flawless, indestructible artificial islands permanently locked into the deep-sea bedrock, completely immune to the violent, roaring currents of the Akashi Strait. With the subterranean oceanic warfare successfully concluded, the structural engineering battalions launched a terrifying vertical assault into the sky. From the massive concrete foundations sitting violently in the sea, two colossal steel towers began to aggressively climb upward, reaching a vertigo-inducing height of 282 meters above the churning water. These towering steel monoliths had to support the crushing, immense kinetic weight of the longest main span in human history, measuring a mind-bending 1,990 meters across the empty void. But height brings a fatal, invisible enemy: extreme high-altitude wind shear. The Akashi Strait is notoriously battered by violent, high-speed typhoons carrying winds that exceed 80 meters per second. If these colossal steel towers were built completely rigid, the aggressive storm winds would act like a massive hydraulic press, violently pushing against the steel until it suffered catastrophic aerodynamic resonance and snapped under the immense torsion. To completely weaponize the structure against the atmosphere, engineers designed the towers to be highly flexible, dynamically bending and swaying with the violent winds rather than rigidly fighting them. Inside the massive steel legs of the towers, they installed highly advanced, cybernetic tuned mass dampers. These are massive, heavy-duty pendulums weighing dozens of tons, connected to complex hydraulic shock absorbers and advanced computer sensors. When a violent typhoon aggressively slams into the tower, pushing it in one direction, the heavy mass dampers are dynamically fired in the exact opposite direction. This highly calculated, brutalist mechanical counterweight completely neutralizes the aerodynamic resonance, instantly killing the kinetic vibration and keeping the massive steel towers perfectly stable, even in the absolute worst atmospheric storms on the planet. As the colossal towers pierced the clouds, the engineers initiated the most terrifying high-stakes phase of the entire megaproject: the aerial spinning of the massive main suspension cables. The entire mind-bending weight of the massive steel highway deck had to be entirely supported by just two brutalist arteries of high-tensile steel draping elegantly between the towers. These cables could not be lifted. They had to be manufactured strand by strand, hundreds of meters in the empty sky. Specialized automated spinning wheels aggressively pulled incredibly thin, highly refined steel wires back and forth across the terrifying 2-kilometer void, running continuously day and night. The sheer, terrifying scale of this wire-spinning operation completely shatters human comprehension. By the time the spinning was finished, the bridge contained exactly 300,000 kilometers of high-tensile steel wire. If you took all the steel wire from this single suspension bridge and laid it out end to end, it would aggressively wrap around the entire circumference of the planet Earth 7.5 complete times. Workers suspended on narrow, terrifyingly exposed wire catwalks violently compressed these thousands of loose wires into massive singular cables measuring over a meter thick, utilizing heavy hydraulic compactors to squeeze out every microscopic air gap. Every single wire was under immense, terrifying tension, perfectly balanced to distribute millions of tons of kinetic force directly into the colossal concrete anchorages buried deep inside the land. By early January 1995, the colossal structural skeleton of the Akashi Kaikyō Bridge was standing victorious. The massive 282-meter towers were fully erected, and the colossal main suspension cables were perfectly strung across the terrifying 2-kilometer gap. The engineers were preparing to begin hoisting the heavy steel highway deck into place, believing the most dangerous phases of the impossible project were finally behind them. They were completely, catastrophically wrong. The ultimate horrifying test of this megastructure was not going to come from a typhoon or an oceanic current. It was going to come from the deep, violent tectonic crust of the Earth itself. At exactly 5:46 a.m. on January 17, 1995, a completely unpredicted, highly active fault line running directly beneath the Akashi Strait violently ruptured. The Great Hanshin Earthquake, a massive 7.3 magnitude tectonic detonation, aggressively slammed into the city of Kobe and the surrounding oceanic region. The sheer, violent kinetic energy released by this earthquake was completely apocalyptic. The ground aggressively shook with terrifying vertical and horizontal force, violently ripping highways apart, collapsing thousands of buildings, and completely devastating the nearby city. The epicenter of this catastrophic tectonic bomb was located just a few kilometers from the bridge's massive foundations. Deep underwater, the violent seismic shockwaves aggressively slammed into the colossal concrete caissons. High in the air, the massive 282-meter steel towers whipped back and forth with terrifying violence as the massive main cables aggressively snapped and vibrated under the extreme tectonic load. It was an absolute zero-tolerance trial by fire, a real-world doomsday simulation happening live in the middle of construction. When the violent shaking finally stopped and the smoke cleared over the devastated region, panicked structural engineers aggressively rushed out into the churning strait to inspect the multi-billion-dollar megastructure, absolutely terrified that the bridge had suffered fatal, microscopic structural fractures or catastrophic foundation shifting. What they found completely defied belief. The ultra-dense underwater concrete caissons had completely ignored the 7.3 magnitude shockwaves. The highly flexible steel towers and the complex tuned mass dampers had perfectly absorbed the violent kinetic energy, preventing the massive monoliths from snapping. The main suspension cables had held their terrifying tension perfectly. The Akashi Kaikyō Bridge had flawlessly survived a direct hit from one of the most destructive earthquakes in modern Japanese history, without a single piece of steel breaking. However, the engineers soon discovered a terrifying, jaw-dropping anomaly that threatened to ruin the entire project. While the bridge itself was completely undamaged, the earthquake had been so violently powerful that it had physically, permanently altered the geography of the planet Earth. The massive tectonic plates beneath the ocean floor had violently shifted, aggressively ripping the seabed apart. This massive geological shift had physically moved the colossal foundations. The two massive 282-meter towers had been aggressively pulled apart from each other. When the frantic engineers ran their highly precise laser measurements, they discovered that the main span of the bridge was now almost exactly 1 meter longer than it was the day before. This 1-meter tectonic stretch was an absolute engineering nightmare. The bridge was perfectly mathematically calculated down to the microscopic millimeter. Every single heavy steel deck panel, every single vertical suspender rope, and the entire aerodynamic geometry of the megastructure had already been prefabricated in factories based on the original pre-earthquake measurements. Because the massive main cables were already permanently spun and locked into the anchorages, they could not be removed or lengthened. The towers were permanently pinned to the new, shifted seabed. The bridge was mathematically ruined. Faced with an impossible architectural crisis, the engineers refused to tear the bridge down. Instead, they executed a hyper-calculated, completely unprecedented mid-construction redesign. They rushed back to their supercomputers, aggressively recalculating the complex suspension physics of the entire 2-kilometer span to account for the new stretch geometry. Because the main cables had been slightly pulled tighter by the shifting towers, the vertical suspender ropes dropping down to hold the highway deck would no longer align perfectly with the prefabricated steel deck segments. The engineers had to dynamically redesign and manufacture entirely new connection joints, altering the precise spacing of the deck panels to aggressively close the newly created 1-meter gap without compromising the extreme aerodynamic stability required to survive the violent typhoons. It was a massive, high-stakes architectural brain surgery performed on the largest mechanical skeleton ever built by human hands. Operating with absolute, uncompromising perfection, the specialized structural crews returned to the violent, high-altitude skies above the Akashi Strait. Utilizing heavy, custom-engineered lifting gantries, they violently hoisted the massive, 1,000-ton steel highway deck segments into the air, dynamically adjusting the tension and alignment, inch by agonizing inch, to perfectly match the new, earthquake-altered geometry of the colossal suspension cables. They successfully installed a highly advanced, heavily reinforced steel truss deck, specifically designed with deep open-air gratings to allow the violent, high-speed typhoon winds to aggressively blow straight through the highway, completely destroying any catastrophic aerodynamic lift. Piece by piece, the massive steel highway was permanently locked together across the terrifyingly deep void, perfectly integrating the new 1-meter tectonic stretch into the brutalist design. When the final heavy steel pin was violently driven into place, the 1991 Akashi Kaikyō Bridge stood as the absolute, undisputed king of global megastructures. It is not just a bridge, it is a permanent, multi-billion-dollar monument to the sheer relentless arrogance of human engineering. It is a living, breathing mechanical leviathan that permanently dominates the deadliest oceanic strait in Japan, constantly flexing and fighting against extreme tidal currents, Category 5 typhoons, and deep tectonic vibration. By surviving a catastrophic 7.3 magnitude earthquake, completely mid-construction, and forcing engineers to dynamically redesign the largest structure on Earth to accommodate a violently shifting planet, the Akashi Kaikyō Bridge proved to the entire world that with enough heavy industrial machinery, uncompromising mathematical precision, and raw, violent willpower, humanity can successfully conquer the absolute most terrifying and destructive forces of nature.
Check the voltage on relay 7. It's showing red here. Hold on. The tablet says it's stable now. Must have been a transient spike.
Isn't this amazing? Look how high it is, Daddy!